This is lesson 5-3, inequalities in one triangle. First of all, I made a mistake in writing this. Number 1, this should be angles less than the measure of angle 15, not 14. So sorry on that. Anyways, we want to find the angles whose measure is less than angle 15. And we can use the exterior angle inequality theorem, which says that any exterior angle, which is what we have, the angles that are inside it, like this triangle right here, these two angles, 4 and 11, are going to be less than the measure of angle 15. So we have angle 4, angle 11. I also see a bigger triangle right here, which means that angle 3 and angle 2 are also less than angle 15. I also see this triangle right here, which means that angle 7 and angle 4 are also less than 15. And lastly, since angle 11 is less, it's a vertical angle. Angle 9 is also less. So I have 1, 2, 3, 4, 5, 6 angles that are less than angle 15. Letter B, I want to find the angles that measure greater than the measure of angle 5. So I'm looking at this angle right here in pink, angle 5. The angles that will be greater than angle 5 are angle 10, because it's exterior, the triangle, angle 13, which is right over here, outside, I also have angle 12, it's exterior. Also, this angle outside, angle 16. And this angle over here, angle 14. Okay? This is all part of theorem 5.8, exterior angle inequality. Basically, it's telling you that the measure of an exterior or outside angle of a triangle is greater than the measure of either of its corresponding remote interior angles. So not the angle next to it. Okay, I know that it looks like 15 is bigger, but remember in geometry we cannot assume that. So we are not going to list angle 15 because we can't assume that. Number 2, it says list the angles of triangle ABC in order from smallest to largest. And I don't know about you, but I don't see any angles. So I have to use the sides, and I have to remember that my sides correspond with my angles. This side, AB, it corresponds to angle C. That's the smallest side, so that's the smallest angle. The next smallest side is BC, 14.3. So the angle that corresponds to it is directly across which is angle A. So angle A is the next smallest. And the largest side is AC. It's 15.7. The angle that corresponds is right across angle B. It will be the largest angle. These are called angle-side relationships in triangles. And it's very important to remember the relationship between the sides and the angles, because you can tell the angle size by the side, and just like in our next one, you can tell the length of a side by looking at its corresponding angle. Okay, so I want to go from smallest to largest. So the first thing I want to do is find the smallest angle. The smallest angle is angle B. Angle B is going to correspond to the side across from it, which is this side right here, AC. That means AC is going to be the smallest side. The next smallest angle is angle C. It's 55 degrees. The side directly across from it is AB. So AB is going to be the next smallest. And that leaves only one more side. 80 degrees corresponds to that last side of BC. Okay, let's flip it over. And I have a word problem. And it says, during lifeguard training, an instructor simulates a person in distress so trainees can practice rescue skills. If the instructor, trainee 1 and trainee 2 are located as shown in a triangle, which trainee is closest? Okay, so what I want to figure out is I need to know this angle right here, because I need to know, is it bigger or smaller than these two angles? So how can I figure that out? Well, triangle is 180, so 180 minus 60 plus 59. So let's figure that out. What do you get? You should get that it's 61 degrees. Okay, since that's the largest angle, what side is going to be the largest side? If you draw your arrow, this side right here is the longest side. Which angle is the shortest? 59 degrees. So what side is the shortest? Yep, that side over here, from the instructor to trainee 1. So which trainee is closer to the instructor? Trainee number 1. Alright, last example. We're going to use the exterior angle theorem.
Is Becky in here?
No.
No. Okay, sorry.
Okay, exterior angle theorem. Sorry about that interruption. We want to find measures less than angle 4. Okay, so we're looking at this angle right here. It's exterior. We can assume that since it's on this side of the line, we're only looking at this triangle right here. So even though angle 3 may be, we can't count it. But we can count angle 1 and angle 2. So that is our answer for number 1, angle 1 and angle 2. Okay, measures less than the measure of angle 9. Angle 9 is right down here at the bottom. If I look at angle 9, it's at the bottom here. So I am going to be looking at this triangle right here. I cannot count angle 8 because it's a linear pair. Even though it looks it, we're not going to count it because we can't assume. But we can count these two remote interior angles, angle 6 and angle 7. Okay, last one, measures greater than angle 7. So angle 7 is right here. So I'm looking at this triangle again, the same one. So greater than 6 and 8 maybe, but we don't know for sure. We can't assume that. But we can assume, hey, these are exterior angles. They probably are, so we can pick those, angle 5 and angle 9. Those are our two angles that are bigger than angle 7. And the lights just went out. That's it.